Hi everyone. In this video, we are continuing with the chapter called Working with NumPy, but we are going to be concentrating on three topics here. That's reshaping an array, accessing elements of the array, as well as slicing the array. So let's go ahead. Now, what do you mean by reshaping an array? Suppose you have a one-dimensional array. Okay, you already have an existing one-dimensional array. Is there a way that I can convert or change this one-dimensional array into a two-dimensional array? And that is what I mean by reshaping. In fact, into a three also. But I told you that according to your syllabus, you are just going to be learning up to two-dimensional arrays. So when we talk about reshaping an array, we're talking about converting a 1D array into a 2D array. Okay. And for this purpose, we are going to be making use of a function named as reshape that is present in your NumPy module. Okay. So this is the name of the function that we are going to use. And it's present in your NumPy module. So first thing that you need to do is actually import the NumPy module. We've learned this in our previous videos. Okay, the next line here, if you see, is one of the methods of creating a one-dimensional array. You remember in the second video, we had learned about how to create arrays, and there were 5 methods I showed you. One was the array method, where you could specify any elements of the array. One was using the ones method, which fills up the entire array with 1. One was the zeros method, which fills up the array with 0. The fourth one was the arange function, which I'm planning to use here. And the fifth one was the linspace or line space function. Okay, so I hope you have seen video number 2 and have understood all that. Okay, so here we have used the arange function. Now, what does a range of 6 mean? A range of 6 creates elements starting from 0 to 1 less than 6. So it's creating me an array which consists of elements 0, 1, 2, 3, 4, and 5. And where is it stored? Under the array name A. So this is your array A. Okay, this is your array A, and you have created a one-dimensional array using the arange function. Now let's look at this array. How many elements are there? So in this array, the number of elements we see is equal to 6. Okay, now why am I telling you this? This will help me out when I'm doing the reshape. Okay, now look at the next statement here. It says a dot reshape 2, 3. So it says reshape the array A. So you already have the array as a one-dimensional array. You need to reshape it in such a way that you have 2 rows and 3 columns. So you need to be dividing these 6 elements as 2 rows and 3 columns, and that becomes your array B. So if you look at all these 6 elements, how will I divide them into 2 rows and each row having 3 columns? Is you start dividing here. This is row number 1 and this is row number 2. Did I get 2 rows and 3 columns? Yes. So my elements of array B are 0, 1, 2, 3, 4, and 5. Now, if you look at the number of elements in array B, they are also 6, correct? Okay, let's go to the next one. It says reshape. Reshape which array? Array A. So reshape array A once again and convert it to 3 rows and 2 columns. So if I have to convert array A into 3 rows and 2 columns, this would be my first row, this would be my second row, and this would be my third row. That means I'm getting 3 rows, and on each row, I'm getting 2 columns. So array C would look something like this: 0, 1, 2, 3, 4, 5. So all these reshaping methods or the reshaping attributes that you've written here is fine. Reason being, array A had 6 elements. When you reshape it to array B also has 6 elements and array C also has 6 elements. While reshaping, you need to remember the number of elements present in array A should be the number of elements that is going to be there in array B as well as array C. The form may change, but the number of elements have to be the same. Now, look at the last example I've given here. I said 2, 4. So I need 2 rows, and on each row I need 4 elements, which means how many elements do I plan to see in array D? 8 elements, which is not possible because you're reshaping array A, which has 6 elements, to form an array D, which has 8 elements. How can I have 6 elements and form an array which has 8 elements? And therefore, if you write that statement, it shows you an error on your screen. So remember, the number of elements of the final array, okay, that means the one that you're creating, should be equal to the number of arrays in the array which you are trying to reshape. Okay, so if I say print A, obviously this is what I see. This is going to be my A elements. So if I say print A, it's going to show me 0, 1, 2, 3, 4, and 5. If I say print B, you're going to be seeing it like this, but you remember how 2D arrays are shown, each row in a separate square bracket. And if I say print C, I'm going to get 0 and 1, and then I get 2 and 3, and then I get 4 and 5. Okay, now, so this is the reshape function. Now you might ask, is the other way possible? Is the other way possible? Can I reshape a 2D array into a 1D array? Yes, there is a function called flatten. You can go and read about it. Okay, it's not required in your syllabus, but there is a function called flatten, which will flatten a 2D or a 3D array into a one-dimensional array. Is that clear? Okay, so this was about reshaping. Let's go to the next topic that's talking about indexing. Okay, how is the indexing done in a 2D array or a 1D array, and how do you access elements of that array? Okay, so here I am creating array 1. I am creating array 1 using the array function. So I have array 1 created using the array 1 means ARR1 using the array function. What are the elements of the array? 10, 2, 30, 4, and 18. Okay, if I ask you to put the index number, this is 0, 1, 2, 3, and 4. If there's negative indexing here, yes, we said there is forward as well as backward indexing. So this is -1, this is -2, this is -3, this is -4, and this is -5. Okay, ARR2, if you look at it, we can make out that it's a 2-dimensional array. Okay, so I have 1.5, I have 2 point, I have 3 point, and I have 6 point. I hope you remember why 2, 3, 6, which are integers, get converted to floating point. Okay, you have 4 point, you have 5 point, you have 6 point, and you have 8 point. Okay, how many axes does it have? It has 2 axes. 2-dimensional arrays have 2 axes. Axis 0, which represents your row, and axis 1, which represents your column. Okay, now here, how is the indexing done? Across each axis, there is an indexing. For ease purpose, let me just change the color. So you have this at row number 0 and row number 1. This is column number 0, column number 1, column number 2, and column number 3. If you were talking about backward indexing, yes, this would be -1 and -2. This would be -1, -2, -3, and -4. Is that clear? Okay. Now, if I want to access the elements of either array 1 or array 2, how is it done? I hope all these numbers don't confuse you. I'll put the array elements in a box, so you know this is the array elements. The other numbers there are just the index numbers. Okay, so this is your array element. Okay, now how do I access elements of a 1-dimensional array? Just the way I access elements of a tuple or a list. So when I write ARR 1 square bracket 3. It means I'm trying to access element at index location 3. So the element at index location 3 is 4. So my output here becomes 4. Okay. How do I access elements using, for a two-dimensional array? So here it is. If you say 1, 3, it means row number 1 and column number 3. So row number 1 and column number 3 gives me nothing. Look carefully. This is row number 1 and this is column number 3, which gives me output as 8 point. Okay. Now you could have written 1 and 3, which is your indexing on axis 0 as well as indexing on axis 1 in the same square bracket, but separated by a comma. Another way of doing it is you put individual square brackets for specifying the indexing of axis 0 as well as axis 1. So this is the way we access elements of a one-dimensional array or a two-dimensional array. Is that clear? Okay, now let's talk about a very important thing which is called array slicing. Now, when we talk about array slicing, I will have to teach you slicing an array using one-dimensional array or slicing an array using two-dimensional array. I'll be a little quick with one-dimensional array because one-dimensional array slicing is just similar to your list slicing or your string slicing. So I've just given you one or two examples. But when it comes to two-dimensional arrays, I will go a little more in detail. Is that clear? Okay. Now, if you look at the slicing concept earlier, you would have to specify your list name, or your string name. So you have your list name. Then you had to specify where to start slicing. Then you had to specify where to end. Now remember, we never go till the end. We will always be, maximum we can go is one element before the end element. And then we had a step value. And by default, step value was +1. But you could have any kind of step value. Clear? Same concept is here. You specify the array name. You specify where to start slicing. You specify where to stop. I repeat, you don't end at stop. You can maximum go up to one element before stop. And how do I access these elements? Do I access all elements? Then step value will be 1. Do I skip elements and access? Then step value will be something else. Is that clear? Okay. So here I've created an array. And what kind of an array? A one-dimensional array. And the elements are 10, 20, 30, 40, 50, and 60. Okay. So now let me just put indexing for these elements. So it's 0, 1, 2, 3, 4, and 5. Or -1, -2, -3, -4, -5, and -6. Okay. Because forward or backward indexing works fine with arrays. Now when I say print A 2:5, what does it mean? Start at position 2. So I have to start here. And end at position 5? No, end at 1 before 5. So I have to stop here, which means what are the elements that I'm getting from the one-dimensional array is 30, 40, and 50. Okay, what does the second one say? Start at position 1. So let me just have a change of color. So start at position 1, that is here, correct? And end at 6, that means end at 5. Okay, that's here. But there is a step value of 2, which means after I get the first element, which is 20, I don't go to 30, I have to skip count. So I leave 1 and I jump ahead. So I get 40. I leave 1 and I jump ahead and I get 16. Okay, so this is exactly identical to your list slicing. So I've not given you many examples. You can refer to list slicing methods and, be very comfortable with slicing one-dimensional arrays. Okay, so let's look at what is new here is how do you slice two-dimensional arrays? So let's look at slicing of two-dimensional arrays. Now, when you're talking about slicing of two-dimensional arrays, in one-dimensional arrays, because there was only one axis, you specified where to begin in that axis, where to end, and what is the step value. But when it comes to two-dimensional arrays, we are aware that there are two axes, axis 0, which is the row, and axis 1, which is the column. So you can do slicing across the row and you can do slicing across the column. That means you can specify where to start, where to stop across the row with a step value or without a step value. Similarly, you can say where to start and where to stop when it comes to the axis 1 as well. Okay, so that is the reason if you look at the syntax, you have the array name and in the bracket separated by a comma, you have two slicing concepts, the row slicing, where do you want to start, where do you want to stop, as well as the column slicing. Okay, things should be a little more clear when we look at a few examples ahead. Okay, let's go ahead. Okay. Before we start slicing, I've already done the array for you. I have created an array using the array function, and I know very clearly that it's a two-dimensional array because I can see individual square brackets which is specifying individual rows, and finally a major square bracket. Okay, so diagrammatically this particular thing will look like this, like the one that I have drawn here or the one that I have drawn here, but I'm using both of them for two different examples. Okay, let's start putting the indexing 0, 1, 2, and 3. And in my example, since I've not used any negative indexing, I'm just putting the positive indexing. What is the indexing here? 0, 1, 2, 3, and 4. Okay, now let's look at the slicing concept. Can you see the first part? The first part refers to the row slicing. The second part refers to the column slicing. So 1:3. What does 1:3 mean? You start at row 1 and you end at row 2 because there is no step value specified. So step value is going to be 1. So I am going to be considering row 1 as well as row 2. Which are those two rows? This one and this one. So these are the two rows under consideration. Clear? Okay. I've not still got my elements because I need to look at the column slicing as well. Column says you start at 2 and end at step end value is 5, but we don't end at 5, we end at 4. So you start at 2 and you end at 4. So column number 2, column number 3, and column number 4. So basically columns you are looking at this and row you are looking at this. Okay. Now I'm looking at the first and the second row and I'm looking at columns 2, 3, and 4. Now which is the element that satisfies the column as well as the row indexing is nothing but this. So that becomes my first output here. It's 6, 8, 10 in one square bracket, 3, 4, 5 in another square bracket, and because it's a two-dimensional array, you have the other square bracket as well. Is that clear? Okay. Okay, now let's look at example number 2. Okay, so let me just give the indexing there. You have 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay, now come to the example. It says 1:3. This specifies the row. So you're referring to row number 1 and row number 2, right? That means you're looking at this entire row. Fine. But can you see there is no column slicing, which means I am referring to all the columns. So I'm referring to column number 0, 1, 2, 3, and 4. So in short, which are the elements I'm referring to? The entire row number 2 and row number 3. So my answer is going to be 2, 4, 6, 8, 10, 1, 2, 3, 4, 5. And because it's a two-dimensional array, don't forget to put the outer square bracket. Clear? Okay, so this is simpler. As we go ahead, I will slightly complicate it, but don't worry, you will be able to understand all. And if you're able to understand all, definitely you can answer anything that comes in the examination, correct? Okay, so let's just go ahead with the next slide. Here it says, the third example is asking you to do another kind of slicing. Now let's understand what is that. But remember children, before you start slicing, you must see to it that you put the indexing. Now in my example, there is no negative indexing, so I'm still continuing with only forward indexing. Okay, is the row specified? No. So what does it mean? All the rows. Is the column specified? Yes, 3:5. 3:5 means what? Third row and end at the fourth row. I'm sorry, third column and fourth column. So third column and fourth column is this. So basically this is your answer. I'm not showing it to you now. You know that in one square bracket you write 7 and 9, in another one 8 and 10, in another one 4 and 5, and in another one 8 and 1, and finally you put a bigger square bracket. Clear? Okay, let's go to the fourth one. Let me write the indexing 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay, now pay attention. Start at 1. Okay, so I start at 1, so I need to take 1. Stop at 4, that means I have to stop at 3. But there is a skip counting, which means I will not go to row number 2. After row 1, I will have to jump the row. Jump the row means what? I come to row number 3. Okay, similarly, come to the column. Start at 1, so I start at 1. You're supposed to stop at 5. So basically, I'm supposed to stop at 4 maximum, but I have to skip count by 3. So when I skip count by 3, when I start at 1 and 1 plus 3, when I say I come to column 4, that means which are the elements I am looking at. I am looking at this element, this element, this element, and this element, correct? Because the two rows I'm supposed to refer to is 1 and 3. And the two columns I'm supposed to refer to is 1 and 4. So obviously I'm going to get that as the answer. So what's my answer going to be? On the first row, I get these two elements. On the next row, I get these two elements. And finally, because it's a 2D array, I show it like this. Is this clear, children? Okay, let's go ahead. This was a little more complicated than the previous slide, right? Okay, no problem. Let's go ahead with some more examples. Here, remember, before you start doing slicing, what is important for you is to write the indexing. Okay, I'm putting it here, doesn't matter. And I write the index number here as well. Okay, let me do it for this one also. Okay, now I think we can get faster. Row is 3, so there is no slicing. It's referring to row 3, so that's this one. Column is 1:3. That means column number 1 and column number 2. So what do you see there? So it's just 4 and 7. Is that clear? Okay. Okay, now let's look at the sixth one. When you say colon, colon, minus 1, if you remember with respect to the list slicing, colon, colon, minus 1 means you are looking at the elements of the list in a reverse order. So which means what? The first part is the row part, right? So I am looking at all the rows. As of now, I'm looking at all the rows, but I'm looking at them in reverse order. So it is considered as all rows. So I am going to be looking at all rows. But when I display the rows, I will start from the last row onwards, okay? And it says column number 1:3. So you have column 1 as well as 3. So you are basically looking at all the rows with column 1 and all the rows with column 3. But the only difference here, sorry, I made a mistake. Just excuse me. Okay, not column 3. When you write 1:3, it means column number 1 and 2. We don't go up till 3, right? So it's basically these. Okay, now because the row is going backward, you cannot get your answer as 3, 5 first. The first answer you're going to get is 4, 7. I hope you understood. This is the row and -1 says reverse. So you get 4, 7, then you get 2, 3, then you get 4, 6, and then you get 3, 5. And because it's a two-dimensional array, you go like this. Is that clear? So what you need to realize is if you're very well versed with slicing of a list or slicing of a string, there you're doing it across only a single axis. Here you have to do across multiple axes. That means axis 0 as well as axis 1. So I hope things are clear and you will be able to handle any slicing methods. Okay, so bye and see you in the next video.